Welcome to everyone listening. This is Kayla Moeller, and this will be the first teacher recorded lesson, followed by a discussion of the lesson afterward. My teacher lesson was about Punnett squares, and it was to a couple of students that did not master the concept the first time, so I went back to reteach with them to fix the misconceptions they had. So this is the worksheet that we completed. We have some monohybrid crosses along with a couple dihybrid crosses. So the whole objective of this worksheet is to fill out the Punnett squares and figure out the genotypic ratio and the phenotypic ratio of the offspring. Some background information that you guys will need to know is that the school that I'm student teaching at is doing this mastery teaching. So they inherited this form of teaching this year, and it's new to the school and is also new to me. So I'm learning a lot about this mastery technique and the way that they teach this. So the way that they teach this is that it's a student-centered learning environment. So it is student-paced, and the teacher facilitates the students with learning opportunities for their advantage so they can learn the concepts in each section. And we are there for all questions. There's a lot of student-teacher interaction with all the questions that the students have. And this worksheet was one of the learning opportunities that we gave to the students. And these two students were at this worksheet at the same time, and they chose to do it individually. And we encourage the students to work in cooperative learning groups so they can work with each other and discuss this worksheet together. So before the students did this worksheet, they have opportunity to go online and view the teacher-directed PowerPoint. So instead of having a teacher-directed class where the lectures are in front of the kids, we have lectures and the PowerPoints, and when the student gets to a certain section, they view that PowerPoint. So I created a PowerPoint and did a couple examples of Punnett squares. So this is where the technology comes into play. And these students observed that PowerPoint, and they did the worksheet, and then I graded the worksheet, and I saw that they had some misconceptions. So I wanted to go back and fix these misconceptions, and this is where my video starts. Alright, so today we will be going over a little worksheet in a small group with two students that had some misconceptions over the first time, and we're going back to fix those misconceptions. Alright, so we're going to go over Punnett squares. So we are going to read this first paragraph. Daniel, can you do that?
A certain species of animal, black fur, capital B, is dominant over the brown fur, little b. Using the following Punnett square, predict the genotypes and the phenotypes of the offspring. His parents are both capital B, lowercase b, or have heterozygous black fur.
Okay, so heterozygous means that they have two different alleles. So big B and little b. And that's for both parents. So this will be your father, this will be your mother. So let's fill in this first Punnett square.
B capital B, right?
Yep. And we need one from each parent. So it'd be capital B, capital B.
So that means this is capital B, lowercase b?
Yep.
So is that lowercase b, capital B? Or does it
Yep.
matter the order?
We usually put the dominant first. So capital B will come first. Okay, now let's look at our genotypes. So genotype is the allele combination, right? So what percentage is homozygous black fur, or capital B, capital B?
1/4.
1/4, which is 25%, right?
So heterozygous black fur,
50.
50, and then 25, right? So the phenotypes, what's a phenotype, Megan?
It is an individual allele, whatever, right? Yes, no?
Okay, phenotype is the physical characteristic. So it's what you see. So in this case it would be black fur or brown fur. So what percentage would be black fur? So remember, capital B is dominant in this case. So
Is it 75? No.
yep, 75%.
Oh, okay.
25% brown.
And then 25% brown. Yep.
What determines it's black?
If we have
The
the capital B, the dominant allele. So up here it says black fur is dominant over brown fur. So if it has the capital B, it'll mask that brown fur allele to make it black. Alright, Megan, now read this next paragraph.
Now do the same when one parent is homozygous black and the other is homozygous brown.
Alright, so homozygous means
One.
they're the same, right?
Yeah.
So homozygous black means they're both capital B. So like this first one, we'll put the alleles. So capital B up here for one parent. The other parent is homozygous for brown. So it'd be little b. There we go. Okay. They're homozygous black, so they'll be the same.
So that's capital.
So capital B, capital B. That makes sense? And then the other one is homozygous for brown. So it'd be little b, little b. See where that's coming from? Okay. So now we need to fill out this Punnett square. So all of them will be,
The same.
yep.
Capital B, lowercase b.
So fill out the percentages there. So homozygous for black fur is 0%, right? Heterozygous is B. Okay. And then repeat this process again when one parent is heterozygous black and the other is homozygous brown. So let's take one parent is heterozygous black. So it'd be like the first example up here, right? Capital B, lowercase b. And then homozygous brown. So remember on that second example,
Both lowercase b's?
yep, because brown is recessive, right?
Yep.
So let's fill out that Punnett square. Alright, get it, Daniel? Alright, so these were monohybrid crosses.
Yes.
50.
Okay, yep, 50 and 50. Because half of them will have the brown hair and half of them will have the black hair. Alright, so these are monohybrid crosses because they contrast in one characteristic. So we're just doing brown and black fur. So now we'll go to dihybrid crosses. So these contrast in two characteristics. So Daniel, do you want to read that first paragraph?
In dihybrid cross, when two traits are considered, the number of possible combinations in offspring increases. Suppose that black hair is dominant over blonde hair and brown eyes are dominant over blue eyes. What percent of offspring could be expected to have blonde hair and blue eyes?
Okay. So we'll do this first example. It does some of it for us, and we'll have to fill in the blanks. So the father has black hair. It is heterozygous. And the brown eyes, heterozygous. And the mother has blonde hair and blue eyes. So here's the genotypes for the father. So we have these first two gametes here, we need to figure out the last two gametes. So in this case, we need to, can I see your pencil real quick? To figure out these next two gametes, okay, you guys remember foiling in math?
Yeah.
So how they got these two gametes is that, so big B can pair with big E, right?
Mm-hmm.
And big B can pair with little e.
Yeah.
And then
First, outside, inside.
little b can pair with big E,
Oh, yeah.
and little b can pair with little e. That makes sense?
So what would be the dominant in this?
Dominant, okay, remember up here. Dominant is black hair over blonde hair, and then brown eyes is dominant over blue eyes.
It would always be B.
It changes with different characteristics. So black is represented with capital B, blonde is represented with lowercase b. But the dominant will always be the capital B, or capital letter. So, and now we need to fill out the gametes for the mother. So the mother can only give lowercase b and lowercase e. So all of them will be little b, little e, right?
Yeah.
Okay, now let's fill out that Punnett square. Finish the rest. So the parent, the father can only give out a big B, little b, right?
Because dominant is.
We need to put the b's together. So your dad gives off big B, your mom gives you little b. There you go. And now we need to fill out the rest of that. You want to write, Daniel? Perfect.
So after I went back and viewed my lesson, I still didn't feel too good about it because I went away from it thinking that the students knew it, but after I reviewed it, I saw that students really didn't have a full grasp on the concept yet. So areas that I saw that I could improve on is the biggest thing I would say is wait time after I give the students a question. I saw myself saying the answer within at least 2 seconds after I say that I asked them the question. So I think that wait time is supposed to be about 7 seconds. So I think if I asked a question and waited 7 seconds for the students to answer, it would help them think about it longer, and they come up with the answer instead of me just giving them the answer. I also saw that I repeated the word right a lot. So after I explained something, after I explained it, I'd say right. And I never noticed that before. So that's another thing I think I can improve on. And I also think I needed more like student-to-student discussion. So each of those two students, I could have asked them to come together and conclude on an answer together instead of having them do, separate sheets. So they could bring their sheets together and discuss what they have different. So future improvements I would have on that lesson is be more specific on key terms before I go into giving them the worksheet. So like homozygous and heterozygous and dominant and recessive. Those students need to have those key words mastered before they do this lesson. And also show the students examples, then have them construct a cross that relates to them. So I had that example before they did the worksheet, but I also could have them create their own question and do a Punnett score on that. So it could be with their own characteristics, so their face shape or chin shape. So they take their own characteristics from their mom and dad and then create their own Punnett square. Or also with chin shape, or also do their own pet. So their own pet colors. So I think that's how I could improve that lesson and make it more effective for the student. Thank you for listening.